Today, we will be looking at the EVAP vent solenoid on a 2001 Toyota Camry. The topics we'll be covering are the application of the component, the purpose and operation, location in the vehicle, failures, and lastly, diagnostics. The vent solenoid, or vent valve, is a generic name for the component that is found in the evaporative emission system of all OBD2 vehicles. Toyota calls their version of the vent solenoid the VSV, or vacuum switching valve. However, it operates in a similar concept as other manufacturers. You can see identical vent solenoids found on the Toyota Avalon, Sienna, as well as Lexus ES300. This component is required on all OBD2 vehicles as part of the EPA's Clean Air Act. For this presentation, we will refer to the component as the vent solenoid, since that is a common term used in the industry. The purpose of the vent solenoid is to control the flow of outside air moving in and out of the charcoal canister, which collects and temporarily stores the fuel vapors. One side of the vent valve is connected to the charcoal canister, while the other side is connected to the drain hose. The vent solenoid is directly attached to a charcoal canister under the vehicle near the fuel tank. During normal operation, the vent solenoid is open and is controlled by the powertrain control module. When the PCM is supplying power to the solenoid, it will flow air. If power is removed by the PCM, then it closes. The vent solenoid closes when the PCM tests the EVAP system for leaks. If a leak is detected, a DTC will be stored in the computer. Leaks most commonly occur when the solenoid sticks open. At that time, a DTC could appear. Some of those DTCs are the P0440, which is a malfunction with the evaporative emission control system, a P0441, which is an incorrect purge flow of the system, a P0442, which refers to a small leak being detected, and a P0446, which is a vent control malfunction. Failures can also occur from dust and dirt. With the solenoid being located underneath the vehicle, it is prone to drawing contaminants through the drain hose and clogging the component. This will also store a DTC. When it comes to diagnosing the vent solenoid, each manufacturer will have their own service information based on the setup. Toyota steps for inspecting a vent solenoid first requires you to check the continuity of the component by using an ohm meter attached to the connectors of the solenoid. At an ambient air temperature of about 70 degrees Fahrenheit, the resistance reading should be between 37 and 44 ohms. If there is an open or any other reading, replace the solenoid. Next, check if air can flow through the ports on the vent solenoid. During this test, the solenoid should be closed. If air does flow through the ports, then replace the solenoid. Lastly, connect the power supply to the vent solenoid at the same location you did with the continuity test. Again, check if air can flow through the ports with the power supply connected. With the power supply connected, the solenoid should be open, allowing air to travel through. Make sure air can travel through the ports. If not, then replace the vent solenoid. With late model vehicles, this test can be completed using a manufacturer's scan tool. By following these steps, you will be able to diagnose the Toyota EVAP vent solenoid. Thank you for joining me today, and I hope you enjoyed the video.